Yeah, so today's presenter is Marissa Defratti. She's a graduate student at Clark University with a background in GIS. And so she will talk about her research regarding the water security issue in Mexico City. Marissa, please go ahead.
Thanks. Oh gosh, sorry. It's telling me I need to change settings for Zoom too. Okay, let me try one more time. Cool, we can see that, right?
Yep, perfect.
Okay. So, hi everyone. Thanks for coming today, or thanks for watching later. I'm going to talk about some of the research I did as part of a system dynamics class at Clark University that was looking at rainwater harvesting and climate change. So just a short background about me. My bachelor's education was in geography and GIS, so really just like an interdisciplinary lens about looking at a lot of different types of problems, and also the GIS component, which stands for Geographic Information Systems, which is kind of like geospatial data science, was really useful for this project to kind of like process and analyze some data and then think about how we could integrate it better with Benson. And then after that, I worked at Esri for a couple of years, which is a geospatial software company. They make ArcMap and ArcGIS Pro and things like that. And then I left Esri to go to Clark and learn how to combine all of this with more of an environmental science and policy lens. And I don't know what's in the future for me because I'm still job hunting. So this was a class that I had taken last fall semester called System Dynamics of Climate Change and Water Resources. And this was my class group and my professor over here. This was the first time that the university had run a class like this, but they really, really want to integrate system dynamics and Benson into a lot more classrooms. We were kind of ended up being that test group. And then in particular, several of the professors, including Ravi here, they were interested in looking at rainwater and water resource management in Mexico City area. They were doing some research there. And then it's just an area where there's a lot of different stressors. So just a short summary of what those stressors are is they have really, really extreme population growth in Mexico City. So in 2020, there was about 18 million people. And based on some of our projections and different data that we found, 2030 could have 21 million, and 2050 could have up to 31 million, though I think there are physical boundaries that would cut back on that. But just for reference, New York City itself only has 8.38 million people in it. So this is something that's much, much more massive than the biggest city that I think many Americans are familiar with. There's a huge issue of urban subsidence, which if you're not familiar with what that is, it's basically when the land beneath buildings or other types of structures kind of becomes unstable. And in the case of Mexico City, it's because they've vastly drawn out their underwater aquifer, their groundwater, and it's depleted so much that the land above the aquifer is actually starting to collapse in on itself up to 8 meters in some places. And this is a problem because not only are the different buildings kind of like collapsing and cracking in different ways, but a lot of their water infrastructure, their pipes that were kind of placed in one area are also starting to crack and break and leak a lot of water out of the system. There's approximately about 40% of the water that goes into the system is lost from leakages that could be from pipes that are broken from subsidence, or also just pipes that are like old, inefficient, they're buried somewhere where it's just too much time and money to dig it up and fix it. And the other problem is that their system isn't a closed loop, so only about 10% of the wastewater from the city is actually recycled. The majority of it is actually just dumped outside of the city, which is a different environmental problem. And you know, all of that aside, there's also climate change that is increasing the temperature of the area, and it's also decreasing rainfall, but increasing flooding. And how that happens is overall, if you measured how much rainfall the area gets throughout a year, it is less and less and less each year. but those rainfall events aren't evenly dispersed as they normally would be. They're usually huge downpour events. And for a lot of different reasons, usually that, a lot of the surface isn't really permeable, they have a lot of flooding. So this is a diagram of the water infrastructure of the area. You can see on the right, the boundaries of the Mexico City metropolitan area. And then all these lines are the water infrastructure networks. So one of the solutions that the government has come up with is that, since we have less and less water here in the city, we need to expand our pipe system. We need to kind of draw from these different aquifers or water networks further out from the city, which is sort of a good plan, but also there are people and there are communities out there who are using that a lot of times for agriculture. So it complicates the problem further, where if you want municipal water, you're also kind of putting at risk your food systems. And so this is the first model that we built to kind of capture all of that. It's looking primarily at population growth, the water need, and the water supply. You can see my mouse. So we have our population model up here, where we took some data from the census to look at all the population in the city and just did a quick model of, what are the projection estimates for, we went all the way out to 2030 and then 2050, because those are some of the important climate change markers for the models that we'll use later on. Oh, sorry. So we have kind of this diagram here where our population stock is increasing. And then we have some other estimates about how much water need is, which we took from some UN documents about just, how much water does a person need every day to survive. We also have the surface water and the groundwater sources that we pulled numbers from the city government to kind of have a total number of, here is our piped water sources. Like, here are the things that are already established that we know are going to stay in place for this system. And then from our piped water supply, we have about 40% lost to leakages. So again, huge number. We have the piped water usage, which is coming from the water need. And then ultimately we have the wastewater, the sewage outflow that's just being lost from the system and not recycled at all. And so currently we have these 3 points of conflict where the current water supply gives us about 48.6 billion liters of water per month. But if we fix the leakages in the system, it could be up to 81 billion liters of water per month. And we just kind of have this other feedback loop that isn't captured in here because we dug into it, but modeling subsidence turned out to be really, really difficult. And it was one semester, or it was a single semester for the class. But we have the groundwater depletion that's still happening. And then that's leading to a lot of subsidence. And again, that could actually end up increasing the leakage as the different pipe systems break. So even though we held that constant, it's likely that it might get worse in the future. And these are the results from that model. So kind of basic, but if you look at the chart on the left, it's showing population growth and water need, which are rising together, which is just to be expected, right? You have more people, they need more water. And then on the right-hand side, we're measuring this population growth against the piped water supply. So with the current water resources that the city has, when is that population growth going to exceed it? And so what we found was that in October 2033, that's about when those two kind of come into conflict. And this chart down here at the bottom shows that. So what the values are for population and water in 2020. And then by 2030, we have an increase of 3.5 million people. The water need is also increasing, and the piped water supply is also decreasing drastically. So there's more and more being consumed by people. By 2050, there's about 30 million people there, and there's actually a deficit of about 5.9 million liters of water that are just not being met by this model. So as part of the class, what we had to do was take this baseline model and then implement some kind of policy solution. And so what my group was really interested in was rainwater harvesting. And there's this NGO in Mexico City called Isla Urbana, where they have a public-private partnership, and they install rainwater harvesting systems on a lot of single-family homes within the area. Usually they end up being low-income areas where either they kind of have difficulty affording the water, or the network is really just not well taken care of in that area. So they might not even be receiving piped water in the first place. It's kind of hard to know. So this is another system that we integrated into the Vensim, and it was more complicated than we anticipated, but kind of how this works is, so you have the gallon tank here, and then you kind of have this waste tank here. And so when it rains, there could be different types of residue on your roof. So the first flush volume is what it's called. The first amount of water that comes off the roof actually really isn't that good to drink. It could have, like dust in it, leaves, waste, other types of things that you don't really want. So whenever it rains, whenever the system works, it always takes that first flush volume and puts it into like a waste bin. And then everything after that first flush volume gets stored here in the container. And then there's different types of filtration devices for this container, which make the water really safe for people to use for basically everything but consumption. But then if people do want to use it for consumption, they're able to just boil the water and use it that way. And so in our policy intervention, we also looked at the different climate change scenarios. So this is a chart showing the shared socioeconomic pathways, or SSPs, which these are incorporated into the big IPCC reports to kind of say, hey, if we keep developing and emitting fossil fuels, what is our future going to look like? And so there's these 5 scenarios that are rated based on the mitigation and the adaptation. We have one here that's middle of the road, which is kind of like business as usual, like we just kind of keep doing what we're doing right now. But based on pretty much every report I've seen about climate change and where we're going, it seems like we're just going to keep emitting fossil fuels. So for our model, we chose to use SSP5 data, which says that we're continuing to develop different types of fossil fuel like technologies or power plants, be anything from selling more cars on the road. And we focus on mitigation. So in that case, we're not focused so much on reducing the carbon that we're emitting into the atmosphere, but we're trying to do things like draw down or capture it like soil or trees or forests, or those carbon capture facilities that you see. And this chart on the right, which is from an IPCC report, is showing the gigatons of carbon per year that are emitted. And it just kind of validates our choice from the chart on the left that these top 2 lines here show in red where the country's plans and projections are taking us in terms of emissions. The brown line shows where their pledges would take them if they followed them precisely. And then these 2 lines down here show if we want to mitigate our warming to either 1.5 degrees Celsius or 2 degrees Celsius, this is where we would actually need to be emitting. So you can see that there's quite a huge difference between where we need to be going and where we're actually going. And so for this, some pre-processing of the GIS data was required. So there's a website called WorldClim, where they have a lot of the different data from the different climate models that all of the IPCC researchers use from around the world. It's free and open, anyone can go and download it. So I decided to download the MIROC 6, which is just kind of a standard model. The data from that is at a 4.5 kilometer spatial resolution. And then they have data for all of those different socioeconomic pathways. And then they also have it for the different timeframes. So they have it going from 2021 to 2040. And they have one going from 2041 to 2060 of like, here's kind of what the estimates would be. And so all of that was GIS data, which I downloaded and I clipped to the area. So it kind of looks like this. And what you're seeing in the map on the right is that in January 2030, here's what the precipitation estimations are going to be for all of these different areas within the city boundary. And so I would take that for each month of the year we were projecting out to. And this is pretty rough as far as GIS goes, but I would just take an average of what the precipitation is going to be in this area. And that's what we used as our variables in the Vensim. So this is our final model where it incorporates that baseline model looking at population growth and water need and the piped resources, and it incorporates the rainwater harvesting. Oh, I forgot all of this was here. So this was the baseline model over here on the left. That's again kind of feeding all of that population growth and piped water supply. And what we have over here on the right, which was probably the most complicated part of the model for us to build, is okay. So we have rainwater harvested, which is coming from our inflow, which we have some coefficients to model the inflow based on. These are some different volumetric conversions that we have here. But basically it's also multiplied by the number of inhabited buildings, the number of, sorry, it's always really complicated when you look at it and you're like, where do I start? But I think the easiest way would be the number of inhabited buildings, which again, we got from census data. So the number of buildings that could potentially support a rainwater harvesting system. We also have the runoff volume over here. So we have to take off that first amount that's going to be wastewater essentially and let it flow. And another one of the really tricky parts was this model, which is running, you can see up here on a monthly basis. So every month, how much precipitation is going, how much can the buildings really capture and how much can go into that, that rainwater gallon tank. But it's also kind of tricky because we need that gallon tank to still keep all of the water that they would have, a month before or something if it wasn't used. So that was one of the tricky parts of this, which we figured out how to do with basically lots of different arrows and coefficients and a few counters and things like that. And I'm really sad I ended up losing the data for the last slide of this, but what we found when comparing our baseline model of just the water need and the current piped water sources compared to this rainwater harvesting model is that rainwater harvesting can't fully support the water needs of the population as it grows, but it can significantly reduce the deficit into the future, meaning that people will have water for much longer than they would if they just relied on the piped water sources. And something else that we found out at the end that wasn't really captured in this model is that this model really relies on the piped water infrastructure network of all of those pipes everywhere, of all the houses being connected. But seeing as I talked about before, how a lot of the subsidence can end up having a lot more, the pipes break, there's a lot more leakages in the system. And as the city grows, it's also very difficult to kind of build it out to those peripheries to make sure that they have access. So just having a decentralized water system can be really empowering for a lot of people who, might be waiting for water tankers to come and service them all the time. And so that's, if I would continue working on this, I would be more interested in modeling what this system would look like as a decentralized system for rainwater access. And that's all.
Great, thank you, Marissa. Yeah, Richard or Biome Cash, do you have any questions for Marissa?
Would you go over the reasons for the water decrease, the decrease of supply? Again, is it mostly from climate issues?
The supply is decreasing mainly because their main source of water is the groundwater. And to do groundwater recharge, it takes so long to recharge that source. So that's one of the major reasons. And sometimes it is, some of it is climate change related, like they're just going to get less water input into the future.
So the rainfall patterns are changing, and also they're over pumping aquifer.
Yeah.
Does the harvesting of rainwater decrease the aquifer recharge?
No, because the aquifer can't be recharged really well from the city because a lot of it is impervious surface. So the rainwater can't even penetrate down into the ground. Okay. Because it's also so impervious, you have a lot of flooding when it does rain. And so I don't know if the rainwater harvesting would help with that, but if you could deploy it on kind of a larger scale. But I think the main focus with this program is just getting people potable water.
Yeah. Interesting. Doesn't sound like there are any easy solutions.
Yeah.
But I think that's a problem we're going to see in a lot of the southwestern US too, soon, very, very soon, looks like.
Yeah, I'm in California, and so I'm familiar with the droughts and the wildfires, and it's a possible situation we're in.
So when you were, I'm just curious if you know Morgan Ruel at Clarkson.
Oh yeah, he's one of our professors in my department.
Oh, so he's in the same department, yeah. Because he did do some system stuff when he was a grad student here, but not very much. Mostly anyway, it wasn't related to water resources, but it was related to his work in drier areas of Ethiopia. Yeah.
Yeah, I know he teaches a food systems class, and I think they did system dynamics a little bit to the point where they did a lot of like causal loop diagrams. But this was really the first class where they asked us to do like a lot of the modeling and equations and kind of putting all of that together.
Yeah.
But yeah, Morgan's really nice.
So hi, Marissa. Yeah, I think this is a nice presentation and very timely research. Everybody's now talking about how to adopt in this under the climate change scenario. So have you tested your model? I mean what would be the future scenario by considering all the variables that you actually have, put it in your model? So have you done that any kind of by values of the variables? But what would be the future scenario? I mean that like in 20 years, that how much this rainwater harvesting can actually support total water supply in your study area. Have you done those kind of things? Any kind of scenario development?
No, not really. But I've thought about it, and I think like one of the main ones, because the kind of hard part is like bringing the GIS into it now, because a lot of what this relies on is what, in my opinion, is what the land use, land cover types are. And so even if you have a lot of they have the urban sprawl growing out, but it can only grow out so far. And that's also going to affect like housing, how much rainwater can be harvested, even just how much precipitation is over the area. Like if there's less vegetation, basically the air is going to be drier and it's not going to rain as much.
Yeah, I got it. And then what is your actually policy recommendation then? I mean, that if we, as a researcher, I think your work is fantastic. If you can actually show that how under different scenario, rainwater harvesting is playing different role to the policymakers, then they will be like, interested. That's why they will invest like in these things. Because I think what I understand, you need some sort of investment in rainwater harvesting.
Yeah,
it's a part of commercialization of the water supply. So
yeah, I didn't get to do it, but the NGO, the Isla Urbana, they do have, like, in my mind, the way to validate this is like I would need more data about like where are they putting these systems and what is the water supply of that. I know that they kind of have it, but these were times of COVID and everybody was busy with other things, so I didn't get it. But I'd really like to. This project is probably like, I think it's kind of done for me with this, because I'm kind of done with school, but there's a lot of other groups working on it, so it ended up just being another step to help someone in the future.
okay, yeah, I got it.
So in the model, is there a stock for the amount of water that's actually the amount of water from rainwater that's in storage? In other words,
sorry.
So how much?
Sorry.
In the model, is there a stock for the amount of rainwater that's currently stored? I'm just sort of curious how many days of supply or how many weeks of supply are in the store or in the stored water?
Yeah, so we have that here. That's just amount of rainwater harvesting.
So that's
amo-
in cubic meters or something like that.
Yeah, and then this has a cap on it. And so anything, so like it's always being pulled out for usage. But if it would ever run over that cap, then that would just flow basically to runoff.
Uh-huh. But do you have any idea of how big that could be? I mean, what size cisterns would people have in their houses and that sort of thing? Or is this, is the system you're talking about as individual house level?
Yeah, they're individual house level, and we use the measurements from the Isla Urbana the tanks for how big those would be that they install.
So,
And they don't know how to do it yet on multifamily dwellings. So it's just single family homes now.
So those are what per family, a couple of cubic meters, or do you have any idea?
So this is basically the size of it. I don't remember off the top
okay.
of my head. Yeah.
Yeah. Yes,
I
sir.
should also say I built this with two other folks. One of them spoke Spanish, so that was very useful.
Now, I think that Richard, you actually asked a very good question. In fact, I mean that household water use is really a matter. That how much water they are getting from different sources, like from municipality sources or maybe other different kind of sources. Understanding those, the water amount would be, I think, very good in terms of developing this as a scenario model in future. Otherwise,
Yeah.
and then you can actually, I think you need some sort of kind of estimation that the percentage of water maybe or in cubic meter, or maybe you can, I think that you can also use that average household water use for a person, like 5 people there, and how much. I mean, there are different, I think, different ways of doing it. Yeah, so I think that that is a really a good question, Richard.
It reminds me of a place I lived in Indonesia when I first went there in the early 80s, 1980s. The house I lived in, it was in sort of a fancy neighborhood of a bigger Indonesian city, not Jakarta, but another one. And that house had a cistern of, it was probably 4 cubic meters or maybe even bigger, but it didn't collect any rainwater. The system they had there, because the municipal water supply was so unreliable, that whenever water came in, people would store it. So you can imagine the kind of, if you tried to model that, it'd be very confusing, because once the water goes on, then the demand goes up, because everybody's turning on their tap to fill up their cisterns. And in fact, their traditional system makes use of cisterns where you dip water out and take your bath by dipping water out. But these were much bigger things, and they even installed pumps to suck the water from the municipal system. And of course, the people who had the bigger pump would get the water, and then they'd be sucking the water from someone else's house. It was really crazy. When I realized how it worked, I couldn't believe it. It was so ridiculous.
You are absolutely right. That is the, I think, common scenario in developing countries, urban area,
Yeah.
That is also happening in India and Bangladesh, sucking others' water. So because they know that when this water is coming, so every house, they also have their own pump to suck that water and fill. And now rainwater harvesting is a very, I think that right now is one of that adaptation strategy in coastal Bangladesh. That's why I'm really interested, because of the sea level rise, the groundwater is becoming saline. So only one option there is actually to harvest rainwater. Now we also faced the same problem, because that those rainwater harvest techniques are not properly maintained. One thing, there is a health issue, a lot of health issue, and again they are also not, that sufficient to provide fresh water whole year round. That is another point, you know.
Mhm.
And then as a result, what we found that especially the women, they're spending their time like 5 hours or 4 hours in collecting water far away, like 20 years or 30 years. And then that has another kind of a socioeconomic impact, and including the health in that area. So that's why I'm actually interested that what Mexico is doing there. Maybe that would be interesting for me. But anyway, I think this is a interesting study.
One thing I was surprised at in Indonesia is they don't do a lot of rainwater harvesting. I don't know why. There's very little. I mean, they have cisterns in some of these houses, but they don't harvest it. I mean, in those areas that I'm thinking of, the groundwater is fairly sufficient, although it's not very good quality. It can vary. And if you get in Jakarta, then you have the problems like you're saying with saline water intrusion and subsidence of land, and it's a real big mess. And in fact, they have a plan to move the government from Jakarta to another place, similar to what they did in Brazil. But I don't know if Indonesia will ever really do that. They keep talking about it.
I think that what you said right now, that why they don't do water harvesting, that also related with some kind of cultural, that practice, because those countries were full of water, in past. So from the childhood, they became the habit of misusing water, instead of storing water or thinking about that, okay, rainwater can be used. So rainwater is always considered as not as a drinkable water after a few days. That is one of the problems. So they have some kind of, what I saw in Bangladesh, because they have some kind of restriction accepting that as a drinking water, unless they are sure that there will be no any health hazard, So those may be another reason, So I mean,
we lived in a very rural part of Indonesia at one point, and we harvested water from the roof of our boat. It was in a wetland area, and the local people were saying, oh, you shouldn't be doing that. That water's not good for you.
Yeah, it's a cultural barrier actually. So that will take time to I think that through awareness and other things.
I think a lot of it, just like looking at a lot of the different climate adaptation strategies and such, it's like a cultural shift that people have to undertake, or they will undergo, to kind of like be more adapted to these systems. Or I even know, and like the ecosystem around them. Like I know in Mexico City with that, one of the problems they faced is like if something broke in whatever that setup was, like they don't always know how to fix it, or they don't have the resources, or different things like that. And there wasn't anybody kind of managing like what happens after we install it. So yeah, there's a lot of stuff to be done.
Have you ever heard of a program called Aquifer? It's I think it's based here at Cornell. It's sort of I think it was started here. It's based, but it's something where they have students. It's almost like a student-run NGO where they go to different. But I think it's more of a rural, village level. But they install water systems that can be, but they're particularly careful about that particular aspect, that it has to be locally maintained. In other words, they have to design it in such a way that it can be maintained locally, and they don't need parts from somewhere else. But it's a systems that they're trying to design for villages and so forth.
Yeah, similar. I am working with Dadala Institute of Global Health Research at York University in Canada. So we also have a project in Sudan. We call that project Rainmaker. So it's locally designed to harvest rainwater, not only for drinking water, but also for agriculture purpose. Because Sudan is, some part of Sudan is facing drought, and so, but that is actually locally maintained. Again, so there is a lot of issues of technology, that how to harvest it, how to store it, and how to use that water more efficiently for agriculture purpose. There are a lot of issues, but I think there are a lot of initiatives around the world, local initiatives. maintained by the local people.
Have you ever seen anything where they're kind of managing landscapes to create more rainwater? Like in an area, if there was Mexico City, like making sure that there is sufficient vegetation and forests around it so that you have that respiration that like, that there's more moisture in the air because of that, this is just something I
That
had.
would have to be at a very large scale, I think.
Absolutely, yeah.
I think a more likely type of thing is to make sure that the landscape will produce stream flow. And that has, it's an interesting thing because the more it's fairly complicated. It's watershed hydrology, basically. And I noticed that I worked at a forestry school in Georgia, University of Georgia, and my colleagues made fun of me when I told them this because they said, oh, you should have known that because I'm in fisheries. But I was camping in the mountains of North Georgia, and I noticed that the river we were near was about 2 inches lower in the late afternoon than it was in the morning. And there hadn't been any change in rain. It's because the trees are taking up the water. And I mean, any forest hydrologist knows that. They were like, of course it goes down. The trees are using the water. But it never had dawned on me that that's what happens. So when you're trying to produce more water from a watershed, sometimes having, I wouldn't say no vegetation wouldn't work because then it all comes at once and then there's none. So it's this idea that the forest acts like a sponge is maybe true, but the forest also uses water, and that water, of course, like you said, goes into the atmosphere and helps to create rain, but that rain is probably somewhere else. There is a couple of, the most obvious example is the Amazon forest. And there have been a couple of recent papers that talk about the importance. Well, there's lots of information about the importance of that as producing rain, but there's been some fairly recent papers that are more quantitative and exactly, the exact effects of that.
Yeah, not only, I think that the tree plantation actually is playing a major role in microclimate as a microclimatic factor, as well as also soil health. Recently, scientists found that soil organic materials has a huge role in terms of evaporation, controlling the rate of evaporation from soil, as well as also for the plants, and then controlling the local, amount of rainfall. So there is a very complex dynamics going on, and now that's why everybody is saying save the soil. Soil health is really important, and that has to be done in a landscape scale. And obviously, forest is the most important, component to maintain the soil health in the water.
Yeah.
So that means agriculture. Then again, here the issue of agriculture and settlement and other things. So it's a very dynamic, system there that we have to consider. Not only planting trees is important.
Yeah, Biomcash, because to talk about organic soil and retain rainwaters, it makes me think of the documentary "The Biggest Little Farm." I don't know if you watched that one.
No, I haven't seen that, but
so there's a couple. They originally live in the Los Angeles, Santa Monica area, and they adopted a dog, and the dog was so loud, so they were evicted out of the apartment. And she's a cook. She's a chef. The husband is like wildlife photography. And so they had the idea of having an organic farm. And so they pitched the idea and finally got investor to buy a 200-acre of land in Southern California. So that one is originally some kind of orchard. Maybe, I can't remember what they planted, but the soil is almost dead. It's just dirt. So they partner with a researcher in like organic agriculture, and so they make worm casting and the juice from the worm, and then restore the land. They do so, for example, they use the sheep to graze between the rows instead of using machine. And they use, so if the lemon trees have snails, they use the ducks to eat the snails. So very organic, and use the chicken to eat the wheat in the garden. So one year it rained really hard in California, and the surrounding areas is just all the water just raw into their farm. But because their farm has better soil quality, it's absorb all of that water. So that is really amazing to see, just the soil restoration can help. Yeah, but you need like 200 acre, right? At least to make a difference. Yeah.
Yeah, I think that's also really important because like we're having problems with the fires where a lot of the wildfires are burning so hot that they're actually killing off all the organic matter in the top layer of the soil. And so they're also like, they didn't used to be that bad at least, but the fires are just burning so much because there's so much burnable, like flammable stuff underneath. And then the soils are also getting so bad where we're increasingly having a lot of landslide problems because if the water comes and hits, there's no like organic matter to hold it. And yeah,
Is the situation in Mexico, there's no water at higher elevations that's dependent on snow, is there? I mean,
I'm not sure.
In a lot of the US at the higher elevations, they're dependent on snowpack in the winter, and it seems, with climate change, it's always a problem, especially in the Northwest. But
that is a big problem all around the world, not only USA.
Yeah.
Himalayan glacier is retreating. Then in Africa, in the classic example in South America, and as a result, the Bolivia and Peru, they are having drought, and part of their migration from Bolivia to USA actually relate to that retreat of the glaciers, because no water, you cannot harvest anymore. So people have to survive.
That's a problem we're gonna have to live with. In India, I think, northern India and Pakistan,
and then there is also geopolitics. If you look at the Indian watershed and Himalayas watershed, you will find China has like 1,200 dam or embankment, and they are diverting all water to China. But interestingly, today I found that China is actually facing a lot of flood today. So that means you cannot actually keep yourself safe from climate change. So you have to cooperate transboundary level.
Yeah. So Marissa, what do you want to do next? Like more research or do something different, or?
Well, I'm back home interviewing for jobs, and I think what I'd like to do is kind of take the system dynamics work and work it into like local government of like climate adaptation planning and strategies and things like that. There's a fellow whose newsletter I follow in Australia, and he's done a lot of work like kind of building it up into the different governments there. So I think that would be really interesting. It's hard to sell because nobody really knows what that means or what it does, or even like GIS in certain situations now, but that's kind of what I'm working towards. We'll see where I end up.
So when you do GIS, does it involve a lot of coding or just using the software itself?
Usually I just use the software. I can probably do, like, I can do small things of code, and when I need to like repeat something 20 times, that's when I'll also use it. But a lot of the time I'm doing like an exploratory data analysis or just trying to do something on one patch of land where for me, it's just easier to like try out different like processes, like analysis tools, and see what I get and do a lot of comparative stuff.
Do you do any spatial modeling?
I've done it a little bit. I had a land change modeling class where we were just kind of doing that, and then I've also done some previous projects looking at deforestation and RED projects, like those carbon crediting.
Yeah, I'm familiar with RED.
Yeah.
I'm not sure. In Indonesia, it's a big deal because people see it as a way to get climate change money to local people if it works. I mean, that was the idea originally. so this mitigation activities can provide, but where does the money go? That's the real question. Where does the money go? Does it really mitigate? And if it does, who gets the money? And that's a very tricky issue.
Yeah, I looked at like 3 in-depth projects. One, I actually had a short-term contract position kind of looking at all of that for companies in Indonesia. And that just looked like, I don't know, I just thought that was kind of a complete mess where there's a lot of projects where they say that they're going to be sustainable and they like pump all the money in, but they're just making a lot of plantations that have a lot of other implications.
Yeah.
And my job was kind of to, like, they had different locals kind of going into the plantation areas and checking on them. And my job was to automate their jobs away from them, which I didn't do that, but that was just very terrible.
No, Indonesia is a very, we lived in Indonesia for about 30 years, 25 years. And my wife worked for C4. Do you know C4? Center for International Forestry Research.
Okay.
It's
yeah.
outside Jakarta. They do a lot of red, or they have done in the past, red stuff. But yeah, it's a very confusing country to work in. I worked on a number of projects, mostly related to fisheries, but it can be very, very confusing. You never really know what's going on. You might think you do, and then 2 years later you'll find out, oh, that wasn't what people were really doing anyway. But so
Richard,
if you found it confusing, that's not unusual.
So when you mention confusing, because I'm from Vietnam, so it's a culture where relationship matters, right? And so I don't know if it's the same thing in Indonesia. Like on paper, people sign everything, but in reality, they don't do anything if you don't have a good relationship. Or how does it work?
Yeah, it's for me the one thing that I found very interesting. In fact, I tried writing a paper about it, was because I worked on a lot of these international development projects, trying to help so-and-so do this, or establishing marine science programs at 6 universities and, all these different things. What happens is the different donors come into someone's office, like let's say someone from Germany comes in the office and says, oh, we're thinking, because they all have their own ideas, the foreign donors. So they come in and say, oh, we're thinking of funding a shrimp project. Would you be interested in that? They never say no. They're not going to say, no, we're not interested in your project. They'll say yes, because they need the money. It doesn't matter what the project is. They're going to say yes. So you get these various, and there's sort of cycles in what the latest subject is going to be. Like RED is one. So that was for several years, RED, all the donors, well, we're going to fund RED and get some of this climate change money out to the rural people rather than just to corporations or whatever. So it went on for years, and they say, oh, we would like to fund a RED project. And some of that money is legitimately needed. I mean, they let's say they have a fishery lab and they need the money. So they say, yes, we'd like that. And, they'll get some money for equipment. They'll get some money maybe for salaries. If it's an Asian Development Bank project, it might be millions of dollars. They also have the opportunity to skim some of this money. So if you're the project director, you and a committee will be in charge of buying equipment. So you can make contracts to buy equipment. Yeah, well, I mean, it's corruption. But because you have these huge amounts of money coming in, it causes more corruption, I think. The World Bank did a study in Indonesia, and I can't remember the title of it, but it was just before Suharto was kicked out of office, but it basically could show he and his family had stolen $40 billion of money from these different projects. And I mean, some of the things, there's several books written on it now about what happened during that period, but the problem after that was under Suharto, I could talk about this for hours, but under Suharto, it was a very centralized government. I mean, that's sort of the way the Indonesian government is when it's centered in Java. That's the way the society is. It's very organized, I mean, it isn't really, but officially you go through your boss and your boss goes through his boss. So you never talk to your second boss up or third boss up. You always have to go through the line. When Suharto, so the corruption was all very organized. You know, you couldn't have a big business. If you got a big business, it was very successful. Very soon you'd find you had some partners who happened to be related to Suharto or knew somebody, you know, so it was that kind of thing. When he left, the corruption became decentralized. I mean, there was just as much corruption, but it was much more confusing for everybody because you never know who was doing what. And fortunately, we, in the positions we were in, we were sheltered from that. But the next level up from us, like I'd be on a project and I would have a manager come from Canada. In one case, it was a company in Quebec running an education project. And she would come and say, oh, I have to go out to dinner tonight to deliver some envelopes. So they had to pay to get their vouchers approved each quarter. So she would show up once a quarter and, you know, say, oh, but she was very open about it. She said, oh yeah, I have to go have dinner with so-and-so. I have to deliver some envelopes. It's like, yeah, okay. But the projects, I mean, they get something done, but there's a lot of waste and a lot of other things.
Well,
I may be too negative, you know.
No, I hear you. I've been in the nonprofit sector before. Yeah.
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 So you're familiar with these problems.
Yeah. It's not new.
I think it's getting better. I'm not sure. I mean, in Indonesia, I think it's gotten a lot better. Just from things we hear.
Yeah.
But getting worse in the US.
It's hard to say.
Yeah. Still a product of the times.
Yeah.
All right. Anything else? Marissa or Cash? All right. So thank you so much, everyone, for joining. It was a fun discussion.
Interesting.